Hello students, welcome back. In the previous classes we have discussed HCF of a number, highest common factor of a number. How will you find the HCF? First we need to find the prime factorization of the number. We use the method prime factorization for finding the HCF, highest common factor. There we use factors of number. There we use factors of number, factors of 6. 1, 6, 2, 3. 1 into 6 is 6, 2 into 3 is 6. So, the factors of 6, 1, 2, 3 and 6. Then, what is the multiple? Factors means the number is that divisible by the given number. Then, what is multiples? Which are the multiples of 6? Multiples, we already know. Multiples of 6, 6 into 1, 6 is the multiple. 6 into 2, 12 is the multiple. 6 into 3, 18. Then 24, 30, 36, etc. are the multiples of 6. First one is factor. Second one is multiple. 1, 2, 3, 6 are the factors of 6. These are the multiples. 6 is the multiple of 6. 12 is the multiple of 6. 18 is the multiple of 6. 24 multiple of 6. So today we are going to discuss about multiples of numbers. In the previous classes we discussed about factors. Now we are going to discuss about multiples. Okay, multiples of 6 are 6, 12, 18, 24, etc. up to infinity. Multiples of 6, 6, 12, 18, 24, then 30, 36, etc. How will you get the multiples of a number? Multiply the given number with the 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay, and the multiples of 12. Which are the multiples of 12? 12 into 1, 12. How will you get the multiples? Multiply the number with the 1, 2, 3, 4, etc. 12 into 1, 12. 12 2s are 24, 12 3s are 36, then 48, etc. are the multiples of 12. First we write the multiples of 6, then we write multiples of 12. From these two numbers, which are the common multiples? Here we can see 6, there is no 6. 12, 12 is there. In the both cases we have seen 12. So, first common multiples of 6 and 12. First is 12, then we can see 24, then 36, then when we write this 42, then we got 48, next is 48, etc. Not ending, there is no end. So, the first four multiples of 6 and 12 are 12, 24, 36 and 48. These are the common multiples of 6 and 12. Out of this, which is highest multiple? Which is the highest multiple? 48 is the highest multiple? No. We can't find the highest multiple because it goes infinitely. There is no end. So we can't find the highest multiple. From this one, we take the lower one. Lowest or least. So here, which is the least common multiple of 6 and 12? 12 is the least common multiple. So we got a new name, least or lowest common multiple. Here the least common multiple of 12 and 6 is 12. So this one is called, we take L from least, C from common, and m from multiple, we got LCM. We got the new name LCM. In the previous classes we have discussed about HCF, highest common factor. Today onwards we are going to discuss LCM, least common multiple. Two are different. First is factor, second one is multiple. How will you find the factors? Factors means the numbers that divides the number exactly. That are the factors. Multiples are when we multiply the number with 1, 2, 3, 4, etc. That is multiple. So remember factors. We use factors for finding the HCF, highest common factor, and we use multiples to find the LCM, least common multiple, highest common factor. Okay. So today we are going to discuss about LCM, least common multiple or lowest common multiple. LCM of two or more numbers is the smallest number that is completely divisible by each of the given numbers. LCM means that is the smallest number that is completely divisible by each of the given numbers. First we need to write the multiples of each number. From that we take common. From that common multiples we take the smaller one. That is the first method. Finding the common multiples, find the multiples of the given numbers, then find the common multiples of the given number, then among the common multiples, the smallest common multiple is the LCM of the given number. The smaller cases, for the smaller numbers, this method is simple. It is not difficult, but for bigger numbers, it is difficult. Here we need to find the LCM of 5, 12 and 15. We know one method. First method is, first we need to write the multiples of each of these numbers. 5 multiples of 5, 5, 10, then 5 into 3, 15, then 20, 25, 30, etc. are the multiples of 5. And multiples of 12, 24, 36, 48, 60, 72 are the multiples of 12. 12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are 48, 12 into 5 60, 12 into 6 72, etc. And the multiples of 15 are 15 into 1 15, 15 into 3 30, 15 into 3 45, 15 into 4 60, then 75, then 90, etc. are the multiples of 15. Here 5, 10, 30, 35, 40, 45, 50, 55, 60, etc. So the multiples of 5, 12 and 15 we got. First we write the multiples of 5, then we write the multiples of 12, then we write the multiples of 15. This method. Is it is difficult? Yes, it is difficult to find. Anyway, from these three, which is the common number, common multiple? 5 is not there in 3 cases. We can see 15 in multiples of 5 and multiples of 15, but we can't see that in 12's multiple. So we can take that one. Then which one is common? Here we can see 16 is the only common number. Then if we move towards, then we got another factors, but sorry, multiples, but here we need to find the least one. Here from common are 60 is common. Then again if you find the other multiples, then we got 120, etc. We got from these two or these multiples, which is the least common multiple, that is LCM is 60. For the bigger numbers, this method is difficult. Anyway, LCM of 5, 12 and 15. That is, first we write the multiples of 5, then we write 12, then we write 15, and we got the answer as 60. So we move to the next method. First one is difficult, so we move to the next method. Second method, that is prime factorization method we use for finding the HCF. Here, find the prime factorization of the given number. We know how will you find the prime factorization. Then from that, how will you find the LCM? For finding the HCF, first we take the common numbers, then multiply it. But here, how will you find the LCM? Product of common prime factors taken once and remaining factors. How will you find the LCM? Product of common prime factors, that means we used for the HCF, taken once and remaining factors. We can do an example. Here we need to find the LCM of 5, 12 and 15. First we need to find the prime factorization of the given numbers. Find the prime factorizations. 5, 12, 15. Prime factorization of 5. We know 1 into 5 is 5. So the only prime number, that is 5. Prime factorization of 12. 2 into 6, 2 into 3. So the prime factorization of 12 is 2 into 3. And the prime factorization of 15, 3 into 5. 3 into 5. So here we got the prime factorization of 5 is 5, 12 is 2 into 2 into 3, 15 is 3 into 5. Here we can't see any common numbers, but we can see 5 in 2 numbers. So take 1 from that, and we can see 3, 2. So into 3 into the remaining numbers. Here 2's are remaining, so multiply 2 into 2. Once more I will tell, I will define the LCM. Find the prime factorization of the given numbers, then take the common numbers as ones. Here we can see 5 is there in the prime factorization of 5 and prime factorization of 15. So we take 5 from that 2 as a pair and we take 1, and next we can see 3 is in 12's factorization and 15's prime factorization. So we take 1, 3 from that, and the remaining numbers are 2 into 2, right? 2 into 2. 2 and 2. We can't take it as a pair because it is in the prime factorization of 12's. There is no other 2's. So we can take only 1, 2. We take these 2 2's. Okay. So 5 into 3, 15. 15 into 2, 30. 30 into 2, 60. We got the same answer as we found using the first method. Here the LCM of 5, 12 and 15, when we use the second method, prime factorization method, we got 60. Prime factorization of 5 is 5, prime factorization of 12 is 2 into 2 into 3, and the prime factorization of 15 is 3 into 5. So LCM means product of common prime factors taken once. That means 5 and 5, we take 1 5 from that 2, and 3 and 3 we take 1 from that 3's, then and the remaining factors are 2 into 2. We write 2 into 2. So we got the answer 16. This method is also little bit confusing. So we move to the next, third method, that is the division method. And now onwards we are using this method to find the LCM. We use the third method, division method, to find the LCM. I will find the LCM using division method. First step is write all the numbers together. Keep dividing the numbers till the remainder is 1. We know the same step we used for the prime factorization, write all the numbers together, but here we write all the numbers together. For the prime factorization, first we write one number and find the prime factorization, then write the second number and then find its prime factorization, then write the third number and find its prime factorization. But here we write all the numbers together. Then keep dividing the numbers till the remainder is 1. We already stop until we found 1. Then the important thing is the numbers that cannot be divided are brought down and divided later by their factors. If one number cannot be divided with the given factor, then just write it down. No changes are there, just write it down. Okay. So first step is write all the numbers together, keep dividing the numbers till the remainder is 1. Then the numbers that cannot be divided are brought down and divided later by their factors. Okay. Anyway, we can do the exercise. Here we need to find the LCM of 5, 12 and 15. First step is write the numbers together. That means write 5, 12 and 15 together and start dividing. Here we know we can't divide this number with 2, the least common multiple, that is 2. We can't divide the 2, 5. We can't divide 5 with 2. So bring down it, write down it 5 without any change. And we know we can divide 12 with 2. 12 by 2 is 6. It is not possible to divide with 15. So write it down. Again, we divide that number with the smallest prime number 2. 5 divisible, not divisible by 2. So brought down that number. Then 6 by 2 is possible. 6 by 2 is 3. Again, bring down the next digit 15. Again, we are going to divide this number with 2. But we know we can't divide the number with 2, this number also with 2. We can't divide 15 with 2. 5 is not divisible by 2, 3 is not divisible by 2, 15 is not divisible by 2. In this case, we move to the next prime number, that is 3. But here we can see we can divide this with 2. So we write 2. But here we can't divide these 3 numbers. So we move to the next number, that is 3. Is it possible to divisible by these numbers by 3? Yes, it is possible. Or not? We can't divide by 5. So we write 5. Then 3 divided by 3, 1. 3. 15 divided by 3, 5. Again, we need to divide this number with 2. Is it possible? No. Then 3. Possible? No. We can't divide 5 with 3. Then we write the next prime number 5. Is it possible to divide with 5? Yes. 5 divided by 5, 1. Bring down. Brought down the same digit 1. Then 5 divided by 5 is 1. Now we got all the digits 1. Now we can stop our division method. Now in the left side you can see some prime numbers. Find the product of these prime numbers. Now we got the LCM. LCM is equal to product of these prime numbers. 2 into 2 into 3 into 5. 2 into 2, 4. 4 into 3, 12. 12 into 5 is 16. So this method we use to find the LCM. Here, to now onwards, we are going to use the third method, division method, to find the LCM. For finding the HCF, we use prime factorization method. But for finding the LCM, we use division method. Third method, division method. Okay, we can do more questions. Anyway, once again I will tell how will you find the LCM of a number using division method. First write all the numbers together, keep dividing the numbers till the remainder is 1. When we found all the remainder is 1, then we can stop. and the numbers then cannot be divided are brought down, just brought down that and divide later by their factors. Okay. So, using that method we got the LCM of 5, 12 and 15, that is equal to product of all devices 2 into 2 into 3 into 5, that is 16. First we divide these numbers with 2, the smallest prime number. We know it is not divisible by 2. So, we just brought down. Then 12 is divisible by 2, 12 by 6, 2 is 6, 15 is not divisible. So, we just brought down it. Then again we know we can divide 6 with 2. So, we divide by 2. 5 by 2 is not possible. So, we brought down that one. Then 6 by 2 is 3, 15, same way, just brought down. Then now we got 5, 3 and 15. Then we are divide that numbers with the next smaller prime. Here we can't divide these 3 numbers with 2. So, we move to the next prime number, that is 3. Then we can't divide this with 5 with 3. So, we just brought down it. Then 3 divided by 3 is 1, 15 by 3 is 5. Now, we got 5, 1, 5. We can divide that number with numbers with 5. 5 by 5 is 1, 1 by 5 not possible, just brought down it. 5 is 1. Now, we got the remainder, all the remainder are 1. So, stop there, and from the left side now we can see 4 prime numbers, just multiply that prime numbers, find the product of all devices. Then we got the LCM. First we need to find the LCM of 20, 25 and 30. Here we need to find the LCM of 20, 25 and 30. First we need to write the numbers together, 20, 25 and 30, and check is it is divisible by 2. Yes, it is divisible by 2 because these two numbers we can divide by 2. 10 into 2 is 20, then 25 is not possible, so write a 15. Again we need to divide that number by 2 because 10 by 2 is possible, that is 5, 25 and 15. Then we can't divide these numbers with the 2 because these all are the odd numbers. So, we move to the next one, that is 3. Is it possible? 3 by 5 by 3 is not possible. 5 by 25 by 3 not possible. 15 by 3, yes, that is 5. Now we got all the numbers as the product of 5. So, divisible by 5. 5 ones are 5, 5 5s are 25, 5 ones are 5. Again divide that number with the 5. 1, 1, 1. Now we got all the remainder as 1. For finding the LCM, we need to multiply the products 2 into 2 into 3 into 5 into 5. 5 into 5, 25, 25 into 3, 75, 75 into 2, 150 into 2, 300. Multiply. 5 5s are 25. 25 into 3, that is 75. Then 75 into 2, 75 into 2 is 75 plus 75, that is 5 into 2 10, carry over 1, 7 into 2 14 plus 1 15, 150. One more of 2 is remaining, just multiply that. 150 into 2, 2 zeros are 0, 2 5s are 10, carry over 1, 2 1s are 3. Answer is 300. So, the least common multiple of 20, 25 and 30 is 300. For that we need to divide all the numbers together. First we write the numbers. We know these two numbers 20 and 30 are divisible by 2. So, we just divide that two numbers. 25 just brought down without any change. So, when we divide 20 and 30 by 2, we got 10 and 15, and we can divide 10 by 2. 10 by 2 is 5. Now, we got 5, 25 and 15. We can't divide these numbers with 2. these numbers are not divisible by 2. So we move to the next one, that is 3. Next prime number 3, we write 3 and we can divide 15 by 3 is possible. So just divide that number and bring down next 2 digits with 2 numbers without any change. Now we got 5, 25 and 5. We can't divide these numbers with 3. So we move to the next one, that is 5. So 5 divided by 5, 25 divided by 5, 5 divided by 5 are possible. So just divide that one with the 5, 5 by 5, 1, 25 by 5, 5, 5 divided by 5, 1. Then only one number is remaining, that is 5. Just divide that number with the same 5 by 5 is 1. Now we got the remainder as 1. Where you find all the remainder as 1, then we can stop. Now the LCM is product of the divisors, that means the product of the prime numbers 2 into 2 into 3 into 5 into 5. 5 5s are 25 into 3 75, 75 into 2 double of 75, 75 plus 75 150, 150 plus 150 300. So LCM of 20, 25, 30 is 300. And the homework question is, let us try 5.5. Question number 1, it's A, B and E, H. These questions are for finding the LCM. Write it in your notebook. All the notes you must write in your notebook. And listen, today we discuss about LCM, least common multiple. We do LCM by the third method, that division method. So you must study or learn the division method. It's very simple. Just write the numbers together and divide the numbers with the possible prime number. Okay, and finally find the product of the prime number. Then we got the LCM. For finding the HCF, highest common factor, we use prime factorization method. First we find the prime factorization of each number. There we do it separately for finding the HCF. But in the case of LCM, we write all the numbers together. Okay, least common multiple, least number where we need to find the least common number we need to find, then we use LCM, the highest common number we need, then we found HCF. Okay, so today's class is over. See you in the next class. Thank you.